Alrighty, I thought we'd look at all these properties with SageCell, and so we need a Z1 and a Z2, and so let's go to SageCell, and I have one up. Now, so I need a Z1 and a Z2, so I think what I'll do is I'll just toss in here an X1, X2, a Y1, and a Y2. So I'll just toss all those in and then define Z1 as X1 plus I times Y1, and define Z2 as X2 plus I times Y2. Okay, so we have those, and now let's try out some properties. Okay, what's the conjugate of the sum or the difference is the sum or the difference of the conjugates. So to try that, I guess what I'll do is I'm just going to do a show and do a conjugate of Z1 plus Z2. So I'll show that, and I will show copied most of it. And then a plus and that. Okay, so we want to get rid of that. Okay, so I need just the Z1 here. Alright, so let's try this, see how it does. So I've got the conjugate of Z1 and Z2, and then I've got the conjugate of Z1 plus the conjugate of Z2. I hit evaluate, and they look the same. So there we go, and I guess I could try it with a minus. So I do a minus, hit evaluate, and again they look the same. So that one seems to work here, and now let's go. Now we want to do the product. Okay, so let's see what happens when I do that. So we've got the conjugate of Z1 times Z2, and then the conjugate of Z1 times the conjugate of Z2. Now let's see if these look alike. They should be equal, but so notice that it did the same thing, but that's not a single complex number. So you know, it's sort of leaving me a little flat. Now what we can do is in SageCell, you can ask it to expand something, or in other words multiply stuff out, and sometimes that's what you need to do to get it to start looking the way you want to. So I'm going to expand both of these. Now, given that they look to be equal here, they still should look to be equal, but let's evaluate. And so they are the same, but again, it's kind of bothering me that it's not putting together stuff. So we could try one more thing, and I'm not sure exactly where it goes. We'll try it at the end. So this is at the end of the expand. I'm going to try saying dot collect, and I'm going to have it collect I. In other words, it's going to try to put together powers of I like a polynomial, so collecting like terms. And okay, so I do that, and you hit evaluate, and you see it didn't do a darn thing. Didn't help it a bit. So now there are other things I can do, right? I can look for the real part, and I can look for the imaginary part. So we could do that to match up each of those. The other thing I might try is, notice that's a lowercase I, even though we used an uppercase I here. It's always worth checking because that's coming out, printing out as a lowercase I. See if it does any better. No. Okay. See, so that didn't work. And it wasn't an error, so I believe I was using it correctly. Now again, I can go check simply by, what I would typically do is go to Google and type in SageMath and collect in this case, because I see, so collect terms. Okay, so this asks SageMath. That's usually a good place to find things. It doesn't always give an answer, but let's see. So, yep, just like I said, it says dot collect and then what you want to collect. There's also a thing of coefficients. So that would be interesting. We could try that just to see what happens. Now that I'll just do it in the first one, coefficients, and I'm going to go back to the uppercase I just to see what it does. Oh, nice. Okay, so this is I to the 0 power and I to the 1st power, and so it did collect those very nicely, and you see it's the x12 and the y12 minus y12. So coefficients of I worked just fine, collect I didn't. And of course, again, the other thing we could do is check that the real parts are equal and the imaginary parts are equal, right? So here I could do real, and down here I could do real. And evaluate. And I get the same thing for the real parts, and I could then also do the same check with the imaginary. So some of this is using technology. It doesn't always do what you'd like it to do for you, but often, not always, but often there are ways to keep working with it and get to what you need. So so I think we've done it though. We've shown property B. Now Z1 divided by Z2. Now this should be interesting. Again, so we'll do the division. let's go up here. I am going to copy these two lines and actually comment them out with my pound signs. And for now, get rid of the expand and whoops, and all of that. Get rid of the expand. I'm having trouble there. And all of that. Okay, but this time I want to do division, and I want to do division. And we'll just start there and see what happens. And once again, you know, it shows the same answer. So it pretty much shows that the first line here is actually taking the conjugate of each one and then doing the division. The question is, can I do anything? Can I get this to expand the way I want it to be? See, so this is not the proper form of a complex number. It is a complex number, but a proper form would have a real part and then plus I times the imaginary part, or minus I. This doesn't have that. I don't think the expand thing is going to work. We can just try it on one of them, so I'll copy that. The reason I don't think the expand is going to work is I don't think it's going to, you know, multiply anything out, but I don't know. We'll see. Oh wow, not at all what I expected. So it really didn't do anything for us. It just split up the x and the y up there. So it didn't give us what we want is a real number in the denominator. And so yeah, that didn't help us. Now we may still need the expand, but since what we got was the Z2 in the denominator, you know, one thing I could do is, if I wanted to make this into the proper form anyway, I could take the conjugate of the denominator here and multiply top and bottom by that. So let's see what happens. So that's the conjugate of Z2. So I'll copy this and I'll multiply top and bottom. So times the conjugate of Z2. Oh wait, I'm sorry. That is the conjugate of Z2. So I need Z2, not the conjugate of Z2. So I need to multiply the top by Z2, and then I'll multiply the bottom by Z2 simply by saying divide by Z2. And let's see what this looks like. Just thinking. Wow. Yeah, didn't do anything. Bummer. Yeah. So I don't know, ways to try to trick it. I don't know if there are any good ways to try to trick it. So we may be stuck with this, and okay, that's fine. But so we're seeing some of the limitations of working with this. again, what we could try to do, since I know that's a complex number, let's check the real part and check the real part here. Now I think I'm going to be careful here. I'm going to put that whole thing in parentheses and then ask for the real part, because otherwise it might give me the real part of Z2 or the conjugate of Z2 and divide the conjugate of Z1 by it. So you got to be careful with parentheses and so forth. So there we go, and so that gave us that real denominator and multiplied by Z2 on the bottom and Z2 on the top. So that was a way to get at this proper form, and again, similarly I could do the imaginary part. Okay, so as you get used to the technology, there's a lot of just playing with it to kind of see what you get. So then here's the imaginary part, and they are both the same, so that's a good thing. Okay, so we, again, the division here didn't exactly give us the result in the form we might have expected, but it's doing the work. Okay, conjugate of Z conjugate. Okay, so now I just need a conjugate of Z1. Oops. And I'll take a conjugate of that again. And so hopefully what we see there, and I don't really need this part, hopefully what we see here is just we get Z1 back, x1 plus I, y1. And there it is, x1 plus I, y1, which is Z1. Another thing you could do, I believe, is you could ask if this is equal to Z1. So let's try that. If I just type in Z1 equals equals. So this is the checking whether there's a true equality here. I'm not assigning, I'm checking an equality. So hopefully this says true. Oh, no, I just didn't do anything. It made an equation. So I'd have to look how to do that basically as a question. Are those equal? So I'll get rid of that. Okay, so that was conjugate. Absolute value. Okay, so come back here, and since I already have conjugate listed here, I'm going to change this to absolute value of the conjugate. And then down here in this one, I'm just going to do absolute value of Z1. Oops, I said Z2, Z1. And get rid of the comment. And evaluate. So let's see what we have. And that was not what I was hoping for, right? So I was hoping for the square root of x1 squared plus y1 squared. That's what I was hoping for. So, as you look at that, it's not at all clear that the two are equal, right? Because it didn't do what we had hoped it would do, or at least what I hoped it would do. So if I put in actual numbers into these, I think it would do it just fine. Right, so I'll put in a 2 and a 7. Now if I do those absolute values, I see that they're equal. But if I go with the x1 and the y1, unfortunately it did not actually compute the absolute values for me the way I expected it to. So again, this is kind of learning your technology and what it will or won't do. So I think as far as symbolics there, we might have to punt, other than going through some other theorem, which we will have here. This one, right? So we could get the absolute value squared is z1 or z times z conjugate. So we can give that a shot, but again, I don't think it's going to do what we would hope. So here's the absolute value, and then let's square it. And then here I just want to take z1 times the conjugate of z1. Now we may need an expand on this first one. I'm guessing on the second one we're just going to see down here x1 plus iy1 in absolute values with a square on it. But we'll see. Yeah, see, so again it kind of leaves us flat there with this one, and here I can get it to be the x1 squared plus y1 squared simply by tossing the expand around it. So I'll copy that, put it up here, and add one more parenthesis. So the top one will do what we would hope, and we get that, but you see this one, I don't think expand will do anything for this. I can't imagine it would, but you never know. Yeah, didn't do anything. So again, there are some aspects that are just not going to give you the form out of it that you would really like. Real part. Okay, so I think this is going to work just dandy. So we'll take, say, z1 plus z1 conjugate and over 2. Okay, so z1 plus z1 conjugate. I'm going to go ahead and put an expand on this, divided by 2. So we've got that, and hopefully we'll just get x1. And we could also, I guess just to be consistent with other stuff we've done, let's see, we don't need an expand on there, so we'll just do z1 dot real, and we should get x1 for both of these. x1 and x1. Lovely. Now if we go to minus and we divide by 2 times I, now be careful, if I put a times here, it's going to multiply everything by I. If I, and let me put imaginary part here, if I do a divide by I, that's oops, divide by I, that is dividing by 2i, because I'm dividing by 2 and then dividing by I. So if I don't want to mess with a bunch of parentheses, that's what I need to do to get the 1 over 2i here times this. Okay, so I'll go back. So I've got my z1 minus z1 conjugate, and so hopefully we'll get y1 in both cases. And we do, y1 in both cases. Now notice, if I did mistakenly put a times I there, so you get negative y1 because I multiplied by I didn't divide by I. Okay, so we needed to do that. Okay, so we got those. Now the polar form. So we've got e to the I theta. Yeah, I don't, let's see. We can get the argument, and so let's do that. Let's just ask what the argument of the conjugate is, and the argument of non-conjugate, right? So, so we've got e to the I theta, and so now if I go here and I want e to the I theta, probably what I'm going to need to do to really convince myself is to put this in terms of a theta. Okay, so I'm going to consider some variable theta, and let's just go in here and call this t. Okay, so now I'm going to let z1 equal cosine of t, and then I sine of t. Okay, so I know the argument here is t, and I've already got a conjugate thing in here, and so let's get rid of stuff here so I can tell what I've got. Okay, so there's the conjugate of z1, and then what I want to do is get its argument. Arg, like a pirate, argument of the conjugate of z1, and down here I'll just get the argument of z1. Okay, so I'm hoping I'll get t in both cases. Or sorry, this should, the first one here, this one, the conjugate should be minus t. Not at all what I was hoping. Right? You know, so that didn't do so well. Now, on the other hand, if we go ahead and let t equal something, so we'll just do it this way, t equals, let's say pi, and I believe to get pi I do a capital Pi divided by 4. We'll find out pretty quickly whether that's correct or not. Now I'm hoping to get a minus pi over 4 here and a pi over 4 down there. So evaluate. So notice, you know, they put the minus, they got the conjugate part right, but let's see. Oh, okay. Pi is not defined. Maybe it's lowercase. And the next thing I'll try is both uppercases. Here we go. Bummer. So it just didn't do it. right? It's not actually giving me that argument of that. So let's see. Now t is symbolic, and I made it pi over 4. Another thing we could try is, these are all numbers here, so I could try the numerical thing. Try saying dot n and dot n. And evaluate. There we go. Okay, so if I make it numerical instead of symbolic, I could actually get to the two numbers, and I get the 0.785 and the minus 0.785. So you know, there I saw it that way, but it just was not at all obvious the other ways. But there we go. We've gotten through all those properties. It took us a while, but a lot of the reason it took us a while was, you know, we're trying to make sure we can use this very nice technology tool. And it's pretty straightforward, but it doesn't always do what you want. So, you know, let that be a lesson to you. If you can come up with a technology that does what you want instead of simply what you ask it to do, you're going to be rich. So we'll stop there.